Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download Spacetime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on Spacetime, confirmation that an Earth-sized planet has been discovered in the habitable zone of our nearest neighbouring star, Proxima Centauri. Evidence that seasonal streaks on Mars may not be water after all. And the dwarf planet Ceres could have lots of water in the form of ice-filled craters. All that and more coming up on Spacetime.
Welcome to Spacetime with Stuart Gary.
Astronomers have now confirmed the discovery of an Earth-sized planet orbiting in the habitable zone of Proxima Centauri, our nearest neighbouring star. As we reported last week on Spacetime, the newly detected planet named Proxima b has about 1.3 times the mass of Earth and is orbiting in its host star's habitable zone where, given the right atmospheric pressure, temperatures would allow liquid water to pool on the planet's surface. So far, more than 20 habitable zone Earth-like planets have been detected. However, until now, all of them are hundreds to thousands of light years away. Proxima b is the first alien planet with the potential for life that's within our reach using present-day technology. In fact, the discovery is being hailed as a major milestone on the road to finding other possible life-bearing worlds within our stellar neighbourhood. Proxima Centauri is part of the Alpha Centauri triple star system, which is located 4.37 light-years away, making it our nearest neighbouring star system. The Alpha Centauri star system is easily identified in southern hemisphere skies, as the more distant of the two pointer stars, showing the way to the Southern Cross constellation. The discovery was made by astronomers using the High-Accuracy Radial Velocity Planet Searcher Instrument, or HARP spectrograph, on the European Southern Observatory's 3.6-metre La Silla telescope in Chile. A report in the journal Nature claims the detection was made using the so-called wobble method, in which astronomers see slight movements in a star's position caused by the gravitational pull of a planet orbiting around the star. By timing the star's Doppler shift caused by Proxima b's gravitational pull, scientists were able to determine that the planet was orbiting about 7 million kilometres from Proxima Centauri, which is only about 5% of the distance between the Earth and the Sun. That gives Proxima b an orbital period around Proxima Centauri of just 11.2 Earth days. But crucially, it places it within Proxima Centauri's habitable zone. While the new exoplanet lies within its host star's habitable zone, scientists don't yet know if the planet has an atmosphere. You see, Proxima Centauri is a spectral type M red dwarf star, far smaller and cooler than the Sun, with surface temperatures of only around 2,000 degrees Celsius compared to the Sun's surface temperature of almost 6,000 degrees, meaning habitable zones around red dwarfs are very close in to the star's surface. And red dwarfs by their very nature are usually very unstable stars, with Proxima Centauri being no exception. In fact, it frequently produces very powerful stellar superflares, which could fry the surface of any habitable zone planet with intensive ultraviolet and X-ray radiation. Astronomers don't know if Proxima b has a magnetic field like the Earth, capable of shielding the planet from the bombardment of high-energy radiation associated with stellar flare activity. The problem is, without a strong magnetic field, the planet's atmosphere would be blown away into space. That's what happened to Mars, turning the red planet from a warm, wet world suitable for life to a freeze-dried, inhospitable desert with just 1/99th Earth's atmospheric pressure. Also, being so close to its host star means Proxima b is almost certainly tidally locked with the same side of the planet always facing the star, resulting in permanent daytime on one side, while the planet's other side would be in perpetual darkness and extremely cold, although there would be some light coming from the system's other two stars, Alpha Centauri A and B. You see, Alpha Centauri is a triple star system. It consists of two Sun-like stars, Alpha Centauri A and B, which orbit each other around a common centre of gravity, and which in turn are both being circled by the system's third star, Proxima Centauri. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star, slightly more luminous and about 10% more massive than the Sun, with a radius about 23% larger. Its binary partner, Alpha Centauri b, is a spectral type K orange dwarf star, slightly less luminous than the Sun, and also slightly smaller, with about 90% of the Sun's mass and about 14% smaller in radius. Orbiting this pair is Proxima Centauri, which right now is closer to our solar system than its two companions and currently located about 4.25 light-years from Earth. During the first half of 2016, astronomers using HARPS regularly observed Proxima Centauri as part of the Red Dot campaign, looking for any kind of Doppler shift in the star's position caused by the gravitational pull of an orbiting planet. Initial observations of a possible planet around Proxima Centauri were first made way back in March of the year 2000. However, a paper wasn't written up till 2013, and the detection wasn't very convincing. So the scientists kept looking. At regular intervals, Proxima Centauri is approaching Earth at about 5 kilometres per hour, roughly human walking speed. And at other times in those cycles, the star appears to be receding from the Earth at the same speed. This regular pattern is repeated every 11.2 days. Careful analysis of how tiny the resulting Doppler shifts were showed that they were indicating the presence of a planet with a mass of at least 1.3 times that of the Earth. However, red dwarfs are very active stars, and their natural brightness variations could mimic the presence of a planet. In order to exclude this possibility, the team also monitored the changing brightness of the star very carefully during the campaign, using the ASH-2 telescope at the San Pedro de Atacama Celestial Explorations Observatory in Chile and the Las Cambres Observatory Global Telescope Network. You may recall back in 2012, the HARPS team announced the detection of a terrestrial Earth-sized planet around another star in the same system, Alpha Centauri b. They reported that the planet, which would have been called Alpha Centauri bb, orbits its host star every 3.2 days, far too close and consequently far too hot to support life. However, a follow-up study last year determined that the detected signal of Alpha Centauri bb was actually more likely an artifact in the data, meaning the planet almost certainly does not exist. Statistical surveys of exoplanets, that is planets orbiting other stars, by NASA's Kepler Space Telescope have revealed a large proportion of small planets around small stars. The Kepler data suggests that scientists should expect to find at least one potentially habitable Earth-sized planet orbiting a red dwarf star like Proxima Centauri within 10 light-years of our solar system. And that's encouraging because red dwarfs are the most common type of star in the galaxy. In fact, about 3/4 of all stars in the Milky Way are red dwarfs. Astrophysicist Daniel Huber from the University of Sydney says the discovery is incredibly exciting because Proxima b is so close to us.
Well, Proxima Centauri b is probably one of the most exciting, or if not the most exciting, exoplanet discovery that we've had in the last few years, if not ever, probably. And it's mostly because it's so close to us. Most of the exoplanets that we have found so far, in particular with Kepler, quite far away. So whenever we think about what else can we learn about the planet, or maybe even, how can we study it, how can we learn more about it, it's always a bit of a problem if the star is so far away and it's basically too distant to get an image of the planet, for example, or study its atmosphere and so on and so forth. And that's really what makes this discovery so exciting. We found a planet right in our backyard, so to say.
It would take thousands to millions of years to reach many of these habitable zone worlds that we've found around other stars, often through Kepler, as you pointed out. The fact that we could get there in, 20, 30 years if the Hawking-Milner proposal goes ahead for a whole bunch of nanobot starships.
Yes, that's a possibility for sure. I mean, for the first time, we can actually, think about exploring a planet outside our solar system, and it's not sort of in the realm of science fiction. Most of the other planets, the Kepler planets, were all exciting, but they were too far away. So you could even say with advanced technology in a few decades or maybe a few hundred years, think about going there. But now, for example, with the Break4 initiative, like you mentioned, there are already plans and technological advances, or at least thinking about the technology that is needed to actually send robotic spacecraft to actually go there on a timescale that is imaginable on a sort of human, timescale, which is very exciting.
As far as Proxima b is concerned, it may well be within the habitable zone of Proxima Centauri, but Proxima Centauri is a red dwarf, and red dwarfs can be rather unstable. Lots of superstellar flare activity. You'd have to be very close in. I'm assuming a planet like this would probably be tidally locked.
Correct. That's the assumption. There are many aspects about this particular planet which make it sort of hard to imagine that it could be habitable, although we don't really know. We don't know the answer to these questions yet. But what we do know from the way that the planet was detected is we know its minimum mass. So we have a good idea of how massive it is, and we know its orbital period, and that allows us to say, well, it's roughly within what we think is the habitable zone where, liquid water could exist. But there are many, many other open questions which could affect, how we think about whether this planet is habitable or not.
Yeah, you need an atmosphere firstly. Putting that aside, there are other issues.
There are other issues, for example, as you mentioned, the activity of the star. So the star itself is much cooler than the sun. It's an M-dwarf, and these stars, in particular Proxima Centauri, in fact, is known to have a lot of flares. So this is basically, a similar mechanism as we see in the sun, stellar flares that produce a lot of energy and, in short time scales, and we don't really know what that would do to the planet or to the atmosphere of the planet if it actually has one. So there are lots of open questions which we don't know the answer to yet, but it's still exciting that we found a planet that's so close and is actually also in the right spot that it could be in that zone, in the habitable zone where liquid water could exist. But again, those are questions that we can't answer at the moment, but of course it doesn't prevent us from speculating as well.
It was discovered with a wobble method, the same method used to find Pegasi 51.
Absolutely, yes. So it's we've come full circle in a way, I guess. So that the very first planet detected over 20 years ago, a little bit more than 20 years ago, was detected using the Doppler wobble method. And this one, the Proxima Centauri planet, was also detected using the Doppler method. And it's really quite an astonishing scientific achievement if you think about the tiny, tiny wobble that needs to be detected in order to actually see this planet, to see the signature. So these are really, really very small signals. So on the order of a meter per second of what you have to actually measure. So it is a very difficult scientific achievement, a technological achievement to do this, and it takes a lot of hard work by a dedicated team, which has achieved this using specialized instruments, HARP instruments, to actually unlock this planet and actually find it.
What do you personally want to find from this Proxima Centauri b discovery?
I think for us as a community, it's definitely excellent news in terms of knowing that a planet is there. We want to know more about it because from the discovery itself, from the wobble method, we only get the mass. We don't want to know its radius. So the next steps would be to actually see whether we can detect the transit. So the other main method to find planets, to see whether Proxima Centauri actually transits in front of the star. Now that would be spectacular. If it transits, then we could get a radius and we could actually get a much better idea about whether it in fact is or could be a terrestrial world, which is what we don't know yet. It could be quite more massive. It could be quite large, and we don't know this yet. So I think the next step is to look for transits, and I know that there's already several teams that are on for this challenge, and we'll see whether that will work out. If it doesn't work out, then it's still great news for the field itself because there will be a mission, an NASA mission called TESS, launched by the end of next year that will specifically look for such planets around our closest star. So even if we don't find a planet where we can measure the radius and the mass and hence the density around Proxima Centauri, there may be others that are, not quite as close. No exoplanet is ever going to be closer than this one to us, but there might be others that are just a little bit further away, but we could maybe learn more about them in terms of what they're actually made of.
And of course, the other important thing about this discovery is that it's more evidence that planets don't just occur around a few stars. They seem to occur around a lot of stars, and the star can be in a binary, or in this case, a triple star system.
Yeah, it's wonderful news because it's sort of confirming what we have learned from Kepler. Kepler was a statistical mission. It looked for 4 years and really tried to understand what is the occurrence rates of planets, how likely is it to find a planet around a given star, and that was sort of part of this roadmap of trying to then build other missions that will specifically look for planets closer in. And the fact that we have found one, that now we know that there is one around the closest star to us, confirms these sort of calculations that were based on Kepler data that already told us that there should be planets everywhere. And this is sort of what we found. We looked, and the team found one right at our doorstep, and that's sort of confirming this positive news that planets are really, more or less everywhere in the universe, and independent of what star it is. Actually, it's not quite true. So we do believe that planets form more likely around some types of stars and less likely around others. And M-dwarfs happen to be the ones that actually do show quite a lot of small planets. So these are the things that are insights we learned from Kepler, and now we're gathering more data around nearby stars that seem to confirm that.
It's an exciting time to be an astronomer, isn't it?
It's absolutely thrilling, yes. Especially on days like this where you get, all this sort of hard work that is going on in various teams around the world trying to find planets. And then, days like this are really quite exciting because it also shows that we're just at the beginning. I mean, we found planets and we have exciting discoveries every month or so, every year now, I guess. But we're really just at the start, and it makes us very optimistic about the future for sure.
Yeah, we're sort of getting to the stage stage where we were finding a lot of exoplanets, and it wasn't news anymore because there was always another exoplanet being found the next day. So people were getting very blasé. But to find one so close, literally our next door neighbour, that's so exciting. That's thrilling.
That's exactly the thrilling aspect about this particular discovery. It's our next door neighbor. It can't get any closer, and it's really quite amazing. When I first read about this discovery, I literally gasped because I thought, wow, this is amazing that it actually turned out to be so close to us, that the nearest planet is so close to us. We were lucky as well. I mean, it didn't have to be that way, but it's fantastic news that it is, and it opens up a whole range of new science that we can do. There are lots of people now thinking about, as we've discussed before, habitability of planets around M dwarfs and what flares and so on can do to that. And there will be a lot more research being done towards that direction now that we know that a planet exists so close to our solar system.
Okay, taking a leaf from the Cosmos TV series now, in your spaceship of the mind, when you can travel to this planet, you can stand on its surface, assuming it's a terrestrial rocky planet, what would it be like on that planet with a big comparatively big red dwarf star so close?
Well, it would certainly be a lot different than what we have here on Earth, that's for sure. And we would also have one star, but you would also have, of course, Alpha Centauri A and B, as you mentioned before. It's actually a triple system, so you would actually have three suns in a way, rising and setting at certain points. So it would certainly, we don't know, as you said, whether it's terrestrial, whether we can actually stand on it, but it would certainly be an entirely different experience than what we have here on Earth.
I'm sort of picturing a rocky desert all bathed in red light from the nearby star.
The radiation from the star would be, in terms of the wavelength, would be much more shifted to the red, of course, yes. But most of the energy output of the star towards redder wavelengths, and that would presumably be the effect that it would have on the appearance of the planet if it would stand on it.
That's Daniel Huber from the University of Sydney. Seasonal dark streaks on Mars, known as recurring slope lineae, which have become one of the hottest topics in interplanetary research, don't hold much water after all, according to new data from NASA's Mars Odyssey spacecraft, which is orbiting the red planet. The new Mars Odyssey results, reported in the journal Geophysical Research Letters, is based on ground temperature readings measured through infrared imaging by the spacecraft's Thermal Emissions Imaging System, THEMIS. Recurring slope lineae have now been identified at dozens of sites on Mars. The dark streaks appear to flow downhill during the local spring and summer, and then fade away again during autumn and winter. The same pattern then repeats at the same location the following year. But the process which causes the streaks is still somewhat of a puzzle. The most likely explanation appears to be extremely salty water melting out of permafrost just below the red planet's surface. That explanation was supported by findings last year, which identified hydrated salts in these flows. Since their discovery back in 2011, recurring slope lineae have always been regarded as possible markers for the presence of liquid water on modern-day Mars. However, the new Mars Odyssey temperature measurements identify an upper limit on how much water could be present in these darkened streaks, and apparently it's only about the same as the very driest desert sands here on Earth. When water's present in the spaces between particles of soil or grains of sand, it affects how quickly a patch of ground heats up during the day and cools off again at night. Scientists were able to quantify the amount of water associated with these features, and the results are consistent with no moisture at all and set an upper limit of just 3% water. Now, some type of water-related activity at the uphill end might still be a factor in triggering recurring slope lineae, but the thing is, the darkness on the ground isn't associated with large amounts of water, either liquid or frozen. That means that totally dry mechanisms for explaining recurring slope lineae should not be ruled out. The new findings are based on several years of thermal infrared observations of a crater wall within the large Valles Marineris Canyon system, a massive split near the Martian equator which dominates the planet's topography. Numerous recurring slope lineae features all sit close together in parts of the study region. So, scientists compared nighttime temperatures of patches of ground averaging about 44% recurring slope lineae features in the area to temperatures at nearby slopes with no recurring slope lineae. The researchers found no detectable difference, even during seasons when recurring slope lineae were actively growing. Scientists admit there's some margin of error in assessing ground temperatures with the multiple thermos observations used in this study, enough to leave the possibility that recurring slope Linear sites differed undetectably from non-recurring slope Linear sites by as much as 1 degree Celsius. The researchers used the largest possible difference to calculate the maximum possible amount of water, either liquid or frozen, in the surface material. How deeply moisture reaches beneath the surface, as well as the amount of water present right at the surface, affects how quickly the surface loses heat. The new study calculates that if recurring slope lineae only have a really tiny wafer-thin layer of water-containing soil, that layer would contain no more than about 3 grams of water per kilogram of soil. Now, that's about the same concentration of water as what you'd find in the surface material of the Atacama Desert and the Antarctic dry valleys, both of which are considered the driest places on Earth. And if the water-containing layer in recurring slope lineae is thicker, the amount of water per kilogram of soil would need to be even less in order to stay consistent with temperature measurements. The research published last year identified hydrated salts in the surface composition of recurring slope lineae sites, which increased when the streaks were active. Hydrated salts hold water molecules affecting the crystalline structure of the salt. The new findings are still consistent with the presence of hydrated salts, because you can have hydrated salts without having enough water to start filling pore spaces between particles. And salts can also become hydrated by pulling water vapour out of the atmosphere with no need for an underground source of water at all. Whatever your interpretation, the new findings are providing a fresh window for understanding recurring slope lineae. The thing is, if recurring slope lineae really were seasonal flows of briny water followed by evaporation, then the annual buildup of crust-forming salt should affect temperature properties. So the lack of any temperature difference between recurring slope lineae sites and non-recurring slope lineae sites appears to be good evidence against evaporating brines. Mind you, the lack of a temperature difference is also evidence against recurring slope lineae being simply cascades of dry material with different thermal properties than the pre-existing slope material, as would be the case with annual avalanching of powdery dust accumulating from dusty air. Scientists have identified permanently shadowed regions on the dwarf planet Ceres which are cold enough to trap water ice for billions of years. The new findings, reported in the journal Geophysical Research Letters, suggest that the giant asteroid had the right conditions for the accumulation of water ice deposits which could still be there today. Scientists with NASA's Dawn mission, which conducted the study, say Ceres has just enough mass to hold on to its water molecules. They identified permanently shadowed regions on Ceres which never receive direct sunlight, and would be colder than similar shadowed regions found at the bottom of polar craters on the Moon and Mercury, both of which are known to contain water ice. On Ceres, they tend to be located either on the crater floor or along a section of the crater wall facing towards the pole. These regions can still receive indirect sunlight, but if the temperature stays below, say, minus 151 degrees Celsius, the permanently shadowed area acts as a cold trap where water ice can accumulate and remain stable. Cold traps were always predicted to occur on Ceres, but none had been identified until now. Scientists made the discovery in Ceres' northern hemisphere, which is better illuminated than the south. Images from Dawn's cameras were combined to yield the dwarf planet's shape, showing craters, plains and other features all in 3 dimensions. Using this input, a sophisticated computer model was developed at NASA's Goddard Space Flight Center in Greenbelt, Maryland, which determined which areas receive direct sunlight, how much solar radiation reaches the surface, and how the conditions change over the course of a year on Ceres. The researchers found dozens of sizable, permanently shadowed regions across the northern hemisphere. The largest is inside a 16-kilometre wide crater located less than 65 kilometres from the dwarf planet's north pole. Taken together, Ceres' permanently shadowed regions occupy around 1,800 square kilometres. Because Ceres is located far from the Sun in the main asteroid belt between Mars and Jupiter, its permanently shadowed regions are far colder than similar locations on Mercury and the Moon. On the Moon and Mercury, only those permanently shadowed regions very close to the poles get cold enough for ice to be stable on the surface. However, on Ceres, these regions which act as cold traps can be found down to relatively low latitudes. Scientists found about 1 out of every 1,000 water molecules generated on the surface of Ceres will end up in a cold trap during a Cerean or Ceres year, which lasts some 1,682 Earth days. Now that's enough to build up thin but detectable ice deposits over 100,000 years or so. And that's the show for now. You can subscribe and download Spacetime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com.
For more, you can follow us on Facebook, Twitter, and Tumblr. Just search for Spacetime with Stuart Gary.
The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
You've been listening to Spacetime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts, or Audio Boom. This has been another quality podcast production from Bytes.com.
Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, this month exploring the mystery of fast radio bursts.